Today we will share some experience from us for the alumina tube application. We'll majorly introduce how to protect and clean the alumina tube for your biomass pyrolysis. Alumina tube is commonly used for high temperature process for the materials treatment. Mostly we will be installed in a furnace that can be used maximum to 1700 Celsius degrees. But for the tubes, you can choose to save budget based on the temperature applied. If you use higher temperature, you choose higher purity, and here listed the difference between the different purity that's related with the temperature application range. In our case, we are using 99%, which is the most good balance tube that performance, the good performance and the lower cost. But if you have a super higher requirement for the temperature and stability, you can choose the high purity aluminum tube, which come to 99.5%. But if your tube is less than 99% purity, you must pay attention that it will affect the maximum temperature applied, come to lower 1300 or 1010. It's no more can afford to be used higher than 1200. So you must pay attention and clearly know your tube purity and to make your tube is affordable for the temperature applied. Come to the disadvantages when we're holding, that we must be clearly know to protect the tube. The most important is the aluminum tube is very easy to be corrected. The crack related with handling, knocking, dropping, and also temperature change, humidity, vapor effect. So when we do the application, we must make sure the heating speed is as lower. Our tube allowed the maximum heating speed is 10 degrees per minute. But this must handle when the tube is come to higher temperature. So when the lower temperature below 300 or below 200, because as the humidity was there to forbid the water vapor increase the pressure rapidly after temperature rise. So we must use the lower speed before the tube was heat up to higher than 200 or 300. And come to higher temperature over 1000, we will be allowed it lower heating speed. This one you can follow our SOP for the heating speed. And come to another one that also affected the life of the tube and lead to cracking is the tube alumina is easy to be reacted with related material, including metal chips, potassium oxide, sodium oxide, calcium oxide, silicon dioxide, carbon powder, or graphite powder. All these will form low melting point compounds that form a glassy layer, which will decrease the tube application temperature and weak the structures. So we must pay attention when your sample contains these related materials. We will be forbid it to become to contact with the one, and also we will be pay attention when this material was applied. We will forbid the material be contact with our tube directly. At this moment, you can use crucible and also don't wash your tube with metal brushes. So we must handle it carefully and clean immediately to forbid the residue to form reaction or stay there with the tube to form glassy layer to lower your tube life and temperatures. Here list some attentions during application. You can read yourself and follow it, like keep tube clean, don't put sample directly in the tube, install the tube symmetrically. This we already done during the installation, and you can handle later when you replace the tube. Follow this and leave enough space between the tube and the adapters. Apply thermoresistant caps. This one must be installed every time, otherwise you will face o-ring cracking and adapter temperature rise problem to lead to risk to operator. And no quick temperature change. This is to forbid the cracking, and we have the temperature limitation in our SOP you can follow. Here we introduce principle during applied alumina you can follow if you're interested, but if you much care about the tube life, you should change your experimental design to fit the method to fit for the protection of tube. So in our principle, we will consider safety first, and then we will be follow our experimental design, because that is the target we are apply the device. Then we will consider tube. Unfortunately, if your budget is quite limited, tube life have to be considered first. You have to be shift some of your experimental design to let it be fit for the protection of tube as much as possible. And a very important thing is don't put your sample under the temperature when the temperature is higher than 150. This is to forbid the cold surface contact with the hot surface lead to cracking. This is a double mention about the reaction to form a low melting boiling point glass layer. You must pay attention. Not use quartz crucible in alumina tube, especially when the temperature is high, because the quartz crucible materials, silicon dioxide, come to pressure control. This we are very highlight during training. So must be use pressure as lower, and also you have to be considered about the pressure increase when the temperature rise. So we have a limitation of the setting pressure from the gas resource. Not use apply high temperature under vacuums. Also we have strictly indicated. The most important is because you are more care about the life of the tube, and you also have been some limited budget to replace the tube frequently. So when the tube applies come to 40 times, you must be carefully observe it and inspect it to forbid the tube has no cracking happened. That maybe lead to explosion or kind of cracking during temperature was rise higher. If the tube condition has been not very good, you can keep the tube as a backup for lower temperature apply, but not in high temperature anymore. This must be very carefully pay attention to the tube life. Mostly theoretically the tube can be around 80 times when you apply high temperature condition, but if your budget was limited, you must be observed properly before you start the next time run. This is some necessary to be done after process. First is strictly clean, and second is inspection the condition of the tube. This will be make sure your tube can be safely conduct one process from another. This come to the contamination that we are faced during biomass process. Mostly is come from the liquid part. that will stay inside the tube and lead to contamination for different times use. Another is the biochar, if it be stay in the tube, the carbon will reactive with the tube and also lead to a lower life and lower temperature apply for future use. So we must pay attention to the by oil that we call it tars, or some types of lower boiling point compound, and also we pay attention to the biochar, the carbon. This is list some conditions for the biomass produced, so you can refer the publication here to forbid the byproduct that's being generated if you don't want them, or to be controlled the product to be stay. The product or the byproduct produced, whether it's be biotars or biocarbons, are more related with the temperature and the heating rate applied. So mostly the tars is come from the primary tars. So if the tars is not your product, you're forbidden to be stay too long at the predicted temperature range. And the secondary tars that will be helpful to form the under the tertiary tars, you have to form the product of your morphology carbons. So the temperature control is very important. Here is related from some biomass product to the carbon product that is related. So the application of temperature, you have to be pay attention. That will be assist you to optimize the condition to generate less tars with more of your product. After the process, this you also have how it's changed from the biomass to our target product, and what have been do during the temperature range. This is during optimized BC, we have to be forbid to be generate more primary tars and middle bodies. That is so you can pay attention to how to control to optimize your condition. To go to your final product, you can refer to the publication cited as the DRO number here. And for us, we are more pay attention to the instrument protection after finished use. So here we have some procedure that when the process was finished, first we use compressed air to blow the solid residues. Then for the liquid residues, we will be wipe them with ethanol or mild detergent. Then if you apply any mild detergent like water or ethanols, you must make the tube being dried before you heat up to forbid cracking. These two treatments we can use frequently. If there is really something was stay there and difficult to be removed, you can do periodic burn-up cycling that we have been discussed, which is do a combination process with oxygen, and also can polish the glacier, but not use metallic materials to forbid metal chip was stay in the surface and lead to a generation of low boiling point glacier that break the tube properties. You can follow the process of this cited at the summary table. Wipe. This is you can soak if, but this one require you to take the tube down. Mostly it's not possible for us to be followed, so we will not use. And we will be majorly use wipe with detergent, then blow with compressed air. If still cannot be removed, we will be follow up with burnout process, and we will use polythene and final. So if the tube was condition is come to very bad, it's come to the replacing time for us to replace a new tube. At that moment, we can try the recovery clean with diluted hydrochloride to remove the stains on the surface and check the condition of the tube to fix application condition for the recovery use. Here cited the treatment for the burnout cycling process, so you can follow this method for the burnout process, which treat the organic compounds with oxygen, but there's a must be pay attention is the temperature cannot rise to 950 degrees centigrade, because the carbon will start to react with alumina tube and generate glass layer when it comes to higher this moment. So we must be heat up the tube step by step. First we will be heat up with nitrogen argon protection to remove the vapor, to forbid later the immediately increase pressure to break the tube by the vapor. Then we heat up to go in, start to introduce the oxygen to under and stay some while under the 400 degree around. Come to the most important treatment stage is during the temperature at 750 degrees centigrade. We will be stay there to remove most carbon residue. Then finally we will do a final treatment to make the temperature below 950. We can make it maximum come to 950, 900. So we will do this. After this, you can go high temperature treatment if you're afraid the previous process contaminated your next run. So before that, you can do burnout cycling below 900, remove most of the carbon residues, then heat up again under argon protection with a blank treatment. Then you can go for further treatment if your tube was really being contaminated.